Very quickly, the product rule says that if I have a log, okay, if I have a log, and I'm kind of looking right here, just going straight down to this part, if I have a log and it says log base b, any base, of m times n, if I have log base b of m times n, then I can expand that log out to be log base b of m plus log base b of n. So if you're multiplying m times n, you can expand your log out into two logs that are being added. Okay? And we're going to focus on when do we add logs, when do we subtract logs, and when do we multiply. So this is an example of when you're adding. You're adding because it's m times n. When it's m times n, you expand the log into the sum of two logs. All right, the next rule says the quotient rule. We all know that quotient is what you do when you divide. So they're going to give you an example. If we have something in log form, log base b of m divided by n. So that's a quotient because I'm dividing. So we can expand that log out into two logs, but we won't be adding this time. We will be subtracting. So when we have the quotient of two values in one log, we expand that out into two logs that are being subtracted. And then the last one is the power rule. The power rule says if we have a log base b of m to a power, of something to a power, we're going to take that little power, we're going to bring it out in front. It's brought out in front of our log, and it's actually being multiplied times your log. It's actually being multiplied times your log. It doesn't say p multiplication symbol, but it does say p logs. That's an understood multiplication. So we call this expanding. Tonight you're going to expand your logs. You're going to turn them into more than one logs, and then tomorrow we're going to take these same three rules and we're going to go backwards and we're going to condense the logs. We'll be given multiple logs and we'll condense them back into one log. So you have your product, when two things are being multiplied, break it down into the sum of two logs. Quotient, when two things are being divided, you break it down into the difference of two logs. And when you have a power, you take that power and you bring it out in front of your log and you multiply it times your log. And if these rules seem similar or familiar at all, it's because logs are equal to exponents. And that's what I wrote down for you. Since we know logs are really exponents, then these rules that we just went over, they're the same as our exponent rules. When we multiply like bases, we add exponents. When we divide like bases, we subtract exponents. And when we raise a power to a power, we multiply. So you can kind of connect the three properties or the three rules for logs back to what we know about exponents, because logs are exponents. So let's take the first set of directions that you'll see in your homework. Use properties of logs to expand. Tonight we're going to expand the problem. We're going to make it bigger. Tomorrow we're going to condense it. We're going to make it smaller using the same three properties. Expand each log as much as possible. Then it says when you can evaluate without using a calculator. That's what we practice at the end of section 4.2. So in example 1, 13 is being multiplied times 7. So I'm going to use my product rule. Okay, and I'm going to expand this into two logs. Log base 8 of 13 plus log base 8 of 7. So if it's log of two things that are being multiplied together and they're telling you to expand, you're going to expand that into two logs that are being added. If you're multiplying, you add the logs. Then you ask yourself, can you evaluate log base 8 of 13 without using a calculator? 8 to what power is 13? 8 to the first power is 8. 8 to the second power is 64. You cannot evaluate log base 8 of 13 without a calculator because it's some number between 1 and 2. So you just leave it there. How about log base 8 of 7? Can't do that without your calculator, so you are finished. Okay, example 2. It doesn't look like we're multiplying, but we are. 9x is the same as 9 times x. So you'll either need to think that or write it. So we're going to expand Using our product rule, log base 9 of 9 plus or minus plus log base 9 of x. We're multiplying the two terms, 9 times x, so we expand that out using the addition sign. Then we check to see if we can evaluate either log without using a calculator. Log base 9 of 9 we can evaluate without a calculator. That turns into a what? A 1. And we can't evaluate log base 9 of x because we don't even know what x is. So that would be your final answer for example 2. Some of your logs will evaluate. They're trying to tell you that in your directions. Evaluate log expressions without using a calculator. Example 3 is another product. Even though it doesn't look like it, that's really 10,000 times x. So we're going to expand that out as log. I'm also realizing that I have a common log. I have a common log because they've not written a base there. I know my base is 10. So log of 10,000 times x is expanded out as log of 10,000 plus log of x. Log of 10,000 simplifies to be 4, because 10 to the first power is 10, 10 to the second power is 100, 10 to the third power is 1,000, and 10 to the fourth power would be 10,000. So if we can evaluate that log and get it to be a 4, then you're going to want to do that, especially when you're solving equations. And that log of x, we don't know what x is, so we can't ever evaluate it without a calculator, so we bring it down. All right, questions about those first 3. That was examples of the product property or the product rule. Yes?
If it helps you understand it better, could you write log base 10x?
You can. You can. But the problems, you don't know it yet, but they're going to get more complicated, and the more you can do in your head, okay, without writing things down. If you have to write it down, write it down, okay? The key is that you get it right. Okay, I'm going to move this last row up so we can look at it. All right, now we're moving to quotients. So let's get that out of the way. There we go. Example 4 is 9 divided by x. So we're going to use our quotient property, and we're going to expand it into log base 9 of 9 minus, because it's the quotient, log base 9 of x. So we're expanding. Everything we're doing tonight is expanding. Once you get your 2 logs, if you have 2 logs or more than 2 logs, you look at each log to see if you can evaluate it without using a calculator. So log base 9 of 9 would be 1, and then you cannot evaluate log base 9 of x because you don't know what x is, so that would be the answer for 4. 1 minus log base 9 of x. One reason that we expand is because when we expand the log, sometimes one of the logs or both of the logs will simplify without a calculator, and that helps us solve our equation later on. Example 5 is another quotient, and it's also a common log. So I have ln of e to the 4th minus ln of 8. We're subtracting because we have a quotient. So ln of e to the 4th, the understood base is e, so that says e to what power is e to the 4th, so that first log simplifies to be 4, and then ln of 8, you can't figure out what to raise e to that'll give you 8, so you just have to leave that as ln of 8. 4 and 5 are examples of quotient properties. Everybody got 5? That's not good. I have nothing left on my little pre-made notes. So let's grab some notes. Apparently they disappeared. So we are on example 6. Okay? 6 is an example of where we're going to use our power property. Okay, we're going to use our power property here. We have log base b of x to the 7th. So the 7 is the power. So according to the power property, we can bring the 7 out in front, and we can multiply it times our log. We use this property a lot when we're solving in the next section. You can evaluate log base b of x. All those are variables, so that would be your answer. In example 7, what do we know we need to do right off the bat? Yeah, radicals and logs do not get along. So what exponent would be the same as taking the 7th root of x to the first power? 1/7. So let's rewrite that problem as ln of x to the 1/7. Then 1/7 is your power. So we're going to use our power rule. We're going to bring the 1/7 out in front of the log, and we're going to multiply it times the log. So we're going to get 1/7 times ln of x. And we can't evaluate ln of x with our calculator, so we leave it just like that. Okay? So the first 7 examples are just walking you through simple expanding problems. And when we get to 8, we're going to have multiple things that are going on. Okay? We're going to have multiple things that are going on. So let's look at example 8. So, as I'm writing, y'all already have this written. What do y'all see? There are really 2 properties going on in this log. Okay, product. So this is really x times y to the 3rd. So I have a product between x and y to the 3rd, and then I also have a power. Okay, so let's start. Because x and y are not both being raised to the same power, let's start with the product rule, and we'll expand it out as log base b of x plus or minus, plus, because this is product, log base b of y to the 3rd. Again, since both x and y are not being raised to the 3rd power, we don't do the power rule first. We go ahead and expand by using the product. And then we ask ourselves, can we simplify anything without a calculator at this point? No, because everything is in variables. We don't even know what that is. And the last thing that you're going to do is you're going to take that power and you're going to bring it out in front of your log, and you're going to multiply it times your log. And so this would be as expanded as it can get. Log base b of x plus 3 times log base b of y. Log base b of x plus 3 times log base b of y. And then I taught you the 3 properties. We just got to look at problems that just get harder and harder. Any questions about 8? All right, let's look at example 9. First thing that I would do in example 9 is I would rewrite the square root of x using a power. What power can we raise x to the first power that represents the square root of x? X to the 1/2. So I'm just going to go ahead and put that. X to the 1/2. Radicals and logs do not get along, so change all your radicals to exponents. So I'm going to first start by using the quotient property because the 1/2 is a power, but it's only attached to your x. So we're going to break it down using your quotient. So it's log base 5 of x to the 1/2 minus, because this is a quotient, log base 5 of 25. X to the 1/2 always comes first, because if it's a quotient, it's the top minus the bottom. All right, log base 5 of x to the 1/2. We can use our power rule here and take the 1/2 and bring it out to the front and get 1/2 times log base 5 of x. That is as simplified as that will get. And then log base 5 of 25 will simplify without a calculator. It simplifies down to the number 2. And then that would be as expanded as you could get. Again, on number 8, since you have a square root in the bottom, I would go ahead and think of that as x plus 1 to the 1/2. And then we have another quotient here. So it's log base 8 of 64. So it's log of the top minus log of the bottom. And some of y'all are going to get so good at this, you may even skip some steps. If you really understand what you're doing, just be careful if you're skipping steps. So final answer is going to be 2 minus 1/2 times log base 8 of x plus 1. X plus 1 is really one quantity, okay? You're not being, nothing's being multiplied there, nothing's being divided, nothing's being raised to a power, so that x plus 1 can stay there. Sometimes people think you can go ahead and expand with the x plus 1. If it's not a product, a quotient, or a power, you're done. Okay? Why did I write example 8? We don't know. That's not example 8. That is example 10. Sorry, I'm like, gosh, we got that many to go. We're never going to make it. Okay, let's look at 11. Okay, so 11, 12, and 13 are where they get. 13 is just like crazy. But we'll do 11. Okay, so does anybody know what property we're going to use first? What's the big thing that's going on? The quotient, okay? I got some powers, I got some products, but the big thing that's going on is I got a top divided by a bottom. So we're going to use our quotient property first. So we'll have log base b of x cubed y minus log base b of z squared. And you do have to write that base b every single time, unless it's a common log. If it's a common log, you won't write the base. If it's not a common log, you have to write that little base every single time. Okay? Now, this is what I call a problem in a problem. So once you get it expanded out into 2 logs, each log actually expands out into more logs. Okay? So this first log, we'll just go with this one first of all. You have x cubed times y. You have x cubed times y. So that first log is going to expand into log base b of x cubed plus log base b of y. I'm going to try to write it right underneath so you can see that those 2 logs come from the log I have in the box. Okay? Then you're going to bring down your minus, and you're going to be really careful here, especially if that second log expanded out into more than 1 log. You've got to remember that you would be subtracting everything. You're subtracting the whole log base b of z squared. So no, you might want to be real careful and put that in a bracket or parentheses here. That second log expands how? 2 times log base b of z. All right. Now, will any of the logs that we have 3 logs, will any of them expand any further? Let's look at each one. Will this first one expand any further? Yes, using the power property. So I can bring the 3 out in front. So 3 times log base b of x. That one's expanded as far as it can go. How about log base b of y? It can't go any further, so we're going to write it down. And how about 2 log base b of z? Can it be expanded any further? Nope. So we just write minus 2 log base b of z. If we had more than one thing in that bracket, we would have to subtract everything that was in the bracket. All right, example 12. We're probably not going to get to 13, but we'll do 12. You've got enough explanations that you'll be able to get pretty far through your homework. Let's look at example 12. What would I do first in example 12? Okay, so this is when I'm going to have a big parentheses, and on the outside of that parentheses, I'm going to have a 1/5. Okay, this is the first time where I've had the quotient or the product where all of it was being raised to a power. So I want to show you what happens here. The power you're going to do first because the power is applied to the x divided by the y. So you're going to bring your power out in front and you're going to multiply it times your log. You're going to bring your power out and you're going to multiply it times your log. And then you're going to look at your log and you're going to say, can I expand log of x divided by y any further? And the answer is going to be, yes you can, because that's the quotient. So this is where I would use parentheses because it's going to be 1/5 times that log. So if you break that log down into more than 1 log, you got to multiply 1/5 times everything you break it down into. So this is going to give us 1/5. Need the parentheses there because that 1/5 is going to be multiplied times both of your logs. You're subtracting because you're dividing. And then the last thing that you're going to do is you're going to multiply each log by 1/5. 1/5. So you're going to have 1/5 log of x minus 1/5 log of y. Oops, sorry, mashed the wrong button.
What is,
Sorry, let me go back. Help me out. 1/5 log of x minus 1/5 log of y. Is there anything that y'all didn't get other than the final answer on that one? I didn't mean to make that go away so fast.
would the base be the understood base?
Base will be the understood. It would be understood 10, and you can't evaluate there, so that would be the answer.